Welcome, class. We're going to talk about applications and why we use radians in calculus. Come on. Get it to advance. Not what I want. I should be able to do that. So the long short answer. We have 360 degrees in a circle because the Babylonian number system was base 60. It was base 60 because it came from the Sumerian system. And the Sumerian system came from two people. The Urians and Akkadians is who we believe it comes from. Sumer resulted from these two people joining as a single civilization. One group had a base 5 number system, counting the fingers on one hand, while the second group also counted on one hand, using their thumb as the pointer at each joint of each finger. So 4 fingers, 3 joints, base 12. When these people with the 12 base number system and the 5 base number system got together as a single civilization, we got the 60. 5 times 12. So both could understand it. And that became the system. So a little bit more of it. The radians are based on arc length, not all the ways that people can count their fingers. So that's different. We only use degrees because human brains can comprehend and remember numbers between 0 and 360 better than they can irrational numbers. Square root of 3 over 2 is very difficult to remember, and it's an added thing. Integers, whole numbers, are easier to remember. Though when we talk degrees, they actually do go down to degrees, minutes, seconds, and so on. Same thing with percent and decimals. Decimals are for math or math approximations, while percents are for soft human brains. Fractions are better for all-round math, though not better when we talk to people. The same thing for mixed numbers and improper fractions. All operations are harder with mixed numbers, but try telling someone that 27/8 of a pizza are left after a party and you'll get the idea. So symmetry. So some relationships we're going to talk about. Function of theta equal to sine of theta is an odd function. G of theta, which is just equal to theta, is an odd function. So what does it take for something to be an odd function? An odd function means you are symmetric about the origin, right? An even function is symmetric about the y-axis. So if we let h of theta be f of theta over g of theta, then if I plug in, another property is that if I plug in a negative theta, I should get a negative version of the function. Well, when we plug negative theta in here, I get f of negative theta, which is the same thing as negative sine of theta. And when I plug in negative theta to g of theta is equal to theta, that's just going to give me negative g of theta. The negatives filter off, and I'm left with just f of theta over g of theta, which is equal to h of theta. So that means it's an even function when the two are combined. Okay? So an even function, let's see. So an even function, if I have f of n and I want to check it, doesn't really matter what it is, if f of negative n equals f of n, then it's odd. If f of negative n is equal to negative f of n, then it's even. Or wait, strike that, reverse that. if f of n equals, this is odd, this is even. Negative is going to give me the exact same thing. This is even. And consider an even function that you know. You guys know f of x equal to x squared. If I plug in a negative x, I'm going to get out the exact same thing as if I plugged a positive x in. That is an even function. That's why this is an even function. Well, no. This is the definition of an even function, which is why this is an even function. But an even function over an even function gives us an odd function. Or an odd function over an odd function gives us an even function. If it's an even function, we know some stuff. We know that the limit, as it approaches 0, should be the same from both sides, right? Because it's even, whatever shape it is, at my, right, this is y, this is x, at this place, whatever that may be, they should be equal. Okay, because coming from the right, and coming from the left, they happen. Even if there was a hole there, right? Even if that couldn't be. So like in this example here, whatever that is, that would be a hole. We can't exist there. Okay, so this is the homework question. Look at it. See the solution. There's your homework. Show that it's an even function. Follow the same guidelines. Genuinely, that's what you're doing. And then you're going to argue that the limit of this function from the left is equal to -1. You're going to argue this, so this is what you're trying to show, because this is true. That's true. So to show the top piece, you're really doing that from the other page. You're just kind of going through the motions. To here, you can graph both of these, right? So if let me see, maybe I'll graph them up here. I'll try to graph them up here. Let me go to a different color. Nope, not that color. All right, so there we go. Now let's put a different color. Let's put a, this will be my, this is going to be my f of theta. We'll use that as f of theta. Okay. So this is going to be my f of theta. And so that's going to be a line doing this. Right? That's all that really is. And then we're going to let this be my sine theta. This will be the f of this theta, right? Okay. That's my sine theta. Right, it kind of continues up. It is a wave. And we're testing it at 0. Right? So if, so now what we can say is something like, that's still pretty large, okay. So, since sine of theta over theta is an even function and the limit as theta approaches 0 from the right, from the right of this is equal to 1, when we put in negative values for limit as theta approaches 0 from the left. Sine of theta over theta, we get sine of negative theta over negative theta, which becomes negative sine of theta over negative theta. Those cancel, leaving us, or this, right? So taking this piece down, sine of theta over theta, which we know that is equal to this piece, right? It's kind of like we're only so much room here. Okay, is equal to the limit of theta approaching 0 from the positive side of sine of theta over theta, which is equal to 1. Thus, the limit of theta approaching 0 from the left of sine of theta over theta is equal to 1. Okay. And I think that's it for this one. Yep. Oh yeah, and that doesn't move with it. Darn it. I have to keep that in mind. All right, go back. You guys, come on. You guys have it? All right.